Hi everyone, today we're going to talk about how to get Druid to join two large tables. So we all know that Druid's amazingly fast. However, you can run into some situations where Druid doesn't seem to be performing very well. And in many cases, I found that instead of, let's say, giving Druid more memory or spinning up more nodes, you can actually optimize the query yourself. So I found is that the Druid SQL optimizer is a little bit less sophisticated than, let's say, other more mature database platforms. For example, Oracle or MySQL, that's had many decades to refine their SQL optimizer. We can take a look at two very simple examples of queries. One is queries where you join two large tables and then you do a group by. Second would be join two large tables and then you filter on one table. Okay, so what would a query optimizer do? So in the traditional query optimizer, in this case, when you do a join of a large table A to a table B that's smaller, and then you group by a field in table A, what it might do is that it will try to do a group by first inside table A before joining table B. But in this case, we found that Druid doesn't really do that, and what it's trying to do is it will join every single row from table A to table B. So what we do instead is that we are going to manually rewrite the query so then we tell the optimizer what to do actually. So you see here, in my case, I'm going to, instead of doing the join first, have it inside the brackets in the large table A, I'm going to do a group by. So what this essentially happens is that um, it shrinks the table A before joining the table B. So it looks something like this, shrinks table A and then joins table B. So you can see here how by writing the query myself, I'm telling the optimizer what to do instead of relying on the optimizer. So within Druid, you can't really provide database hints or anything like that, and tell the optimizer what order you want to go by. So let's take a look at the second example of a very common scenario, which is you have a filter on a table. So in this case, very large tables, about 3-4 billion rows each. And I have a filter condition on table B for the field 4 is less than or equal to 5. So what happens actually with Druid, my finding is that you try to put both tables in memory or something, and then it'll do the join before it'll do the filtering. So in that case, run out of memory, the broker runs out of memory, and nothing really works. But what works really well is if I rewrite my query to be something like I, again, do a bracket, select the table B, and then apply the filter condition on table B. And then from that, I join the table A, right? So this might seem like a very kind of imagined scenario, but in this case, my field 4, table B, was actually a date field. So imagine a very large table that's got, let's say, 5 years of data in it. On table B, what I'm trying to do is, let's say, give me 1 day of data, and then I join. So what are we summarizing here? So if you're running into performance issues running queries against a very large table in Druid, consider writing your SQL. So instead of relying on the built-in native SQL optimizer, just be your own query optimizer.